In this video, we're going to take a look at factoring. We're going to review basic techniques for factoring. In fact, factoring is one of those basic skills that will get you even through calculus. It's something you definitely need to know how to do. The hope is that the more you do this, the more second nature it becomes, and you start to get in the habit of just getting an intuition as to what to do before you even run through the details. We're going to discuss and sort of review the three basic factoring techniques. We refer to them as GCF, which stands for greatest common factor. There's a difference of squares, a squared minus b squared, which always factors into a minus b times a plus b. And the AC method, which is sort of the third method. Now, there are other factoring techniques. There's the factoring by grouping if you have a polynomial with 4 terms. But for this video, we're going to focus on these three. These are the three most common factoring techniques. This is really the order you should think about doing them. And as a quick, even further step back, the word factoring itself means to write things as a product. So when you're doing the GCF, you pull a GCF out, and then you have one set of parentheses. When you have the AC method, you have 2 sets of parentheses. You can always check your answer by doing the distributive property, or in this case, something like FOIL, which is just the distributive property with a binomial and a binomial, or you can use the box method. But every time you factor, you're trying to write something as a product, you should be able to check your answer by multiplying out what you think the answer is. Okay. Now, I think the hardest thing about factoring is always going to be, what is the factoring technique you need to use in order to do it? These all have x squareds, right? Some of these have 2 terms, some of these have 3 terms, but the question really is out of these 3 polynomials that need to be factored, which technique are we going to use? Well, this first one is going to use a GCF because there's a common factor of x, right? Each of these terms has an x. This one fits the a squared minus b squared pattern, so we'll have to figure out what the a and the b are. And this is the AC method. We say that a equals 1, that's the 1 right here, b equals 5, c equals 4. Right, and the idea here is you've got to find 2 numbers that multiply to a times c, and those same 2 numbers have to add to b. Okay, so I'm going to erase this set of work here, and we're going to do a quick review on how to do each of these techniques individually, and then we'll do a little bit more practice, a few in a row for you to try. When you're looking for a GCF, you're looking for something common to each term. It could be a coefficient, it could be a variable, it could be a combination. In this case, the GCF is x. Now, there's a few different ways to go from here. I think at this point, you might be comfortable just sort of thinking about what are the 2 things that need to go in the parentheses here, so that when you multiply the x through, you get back the x squared minus 7x that you started with. So what you fill in here is an x, and then a minus, and then a 7, and hopefully there you can see that x times x is x squared, and x times 7 is 7x with a minus here. Okay? You don't always have to check this on paper, but you should at least check it in your head. Right? This is your answer to the factor problem. Okay? So you can put an equal sign here to say that the original equals this. Okay? Now the second one here, once we recognize it's a difference of squares, it's an a squared minus b squared, we really need to think about what are the 2 perfect squares that are being subtracted. Okay? Well, in order to get x squared, you have to take x and then square it. In order to get 16, you have to take 4 and then square it. So the answer here is going to be x minus 4 times x plus 4. And it doesn't matter if you wrote it x plus 4 times x minus 4, it's still the same answer. Okay? So sometimes you'll see in the book they'll give you 2 answers, one or the other. That's there so that you can check your work, but it's better for you to just give one answer. Now, the AC method gets a little bit more complicated. In this case, the A equals 1, which makes life a little bit simpler. We're looking for two numbers that multiply to 4 and add to 5. This is always the A times C, and this is always the B. In this case, the answers are just 1 and 4. And you have to find the same pair of numbers that works in both sets of blanks. And you have to also pay attention to the sign. So I wanted to start off with all positives here just to keep this simpler. Now the nice thing is, because the A is 1, right, we can actually just drop the plus 1 and the plus 4 into the parentheses, and if you were to do the FOIL, box method, distribute, multiply this answer out, you would in fact see that this does give us back the 5x and the plus 4. Now if A is not equal to 1, then you actually have to do the full method. I'll do it here. We take this 5x plus 4. The full method is to split this 5x up using the 1 and the 4, right, that we had before. Okay. So what you do now is you take the first two in group, you take these two in group. So just to point out again, this 1 and 4 here came from this 1 and 4 here. Okay. Now these first two have a common factor of x, leaving an x plus 1 behind. These next two have a common factor of 4, leaving an x plus 1 behind. Okay. When you look at this now, there's a common factor of x plus 1, which we're going to factor out, and then what's left behind is this x and this plus 4. Okay. Same answer, right? A little bit more work. This method here always works, regardless of whether or not the A equals 1. This method takes a little bit more work. There's always trial and error. Sometimes people can just sort of look at it and fill the parentheses in. That'll be up to you, and how quickly this all comes back to you. Okay. So what I wanted to do here is just give you some more practice. If you want to try these first, you should pause the video here, give these a try, and then you can check the work. I'm just going to work through them a little bit more quickly. In a case like this, the GCF, there's an A common to all three of these. There is no coefficient common to all three, so I'm going to factor the A out. It leaves behind a 5a squared minus 12a plus 3. There's all sorts of room to make mistakes. Sometimes people have the A still here, but if you take the time to look at it and distribute this back, you would see that that would give you 3a squared. That's a good time, a good thing to do to check your work. I'm going to move down and do this problem next. Now in this case, there's a 4 and an x common to both of these, so I'm going to take the 4x out. That leaves behind an x squared minus 3. Okay. And one of the things you're going to have to do is when you do factor a GCF, you're always going to have to look at what's left behind. Right? Here, can it be factored anymore? Can this be factored anymore? In these cases, they can't, but we'll look at problems that you might have to factor twice, just like when you reduce a fraction. Sometimes you have to reduce a fraction twice. Okay? In a case like this, you have a common factor between the 15 and the 12 of 3. There's a common factor of A here and a common factor of B here. So we're going to factor out, I said 3 and I started to write 5, so let me just check that. 3AB, 5, you're going to have an A left behind here and a 4B squared left behind here. Again, I think it's probably better to just get something down and get close, and then you can look at it, erase, add things if you need to when you're checking by distributing. Okay. I'm just going to add a little bit of sort of separation here to help keep these problems a little straight as they're running together. In a case like this, I don't see any coefficient or variable common to all of them, so we'll say that it's prime, okay, which really means it can't be factored. Okay. Personally, I'd rather you say the words can't be factored, which is pretty clear that you know what it means, rather than say the word prime, which you may or may not know what it means. Difference of squares. Okay, these are all differences of squares. Perfect square, what's being squared here minus what's being, oops, I already started to fill it in what's being squared here. Right? Fill in the blanks. You have an x here and a 3 here. So this must be x minus 3, x plus 3. Same thing over here, something being squared minus something being squared. Fill in the blanks. This is a 7. This is an a. So the answer must be 7 minus a, 7 plus a. Again, it doesn't matter if you put the plus first and the minus second. They're all the same. Case here, something squared minus something squared. This is a 5 to get the 25, and an x to get the x squared, a 2 to get the 4, a y to get the y squared. So this must be 5x. I'll do this one plus first just to show you it doesn't matter. Okay. And then this last one here, the first thing I'm going to do is notice that there's a common factor of 2. So I'm going to take out a 2, which leaves me x squared minus 25. And this is what I was talking about on the last slide, right? You have to look at what you're left behind. We know that this is really a difference of squares, x minus 5 and x plus 5. This 2 that was there is still there, right? So the final answer would be this. You would have to multiply all this out to get back to what you started with. Okay. This last slide, this is the AC method. I'm just going to do a couple of these. There's a lot of different ways you could do this. There's the full AC method. There's a shortcut. Some people do something called slip and slide. People draw X's, and whatever works for you is really the way you should go about doing it. I'm going to focus on the AC model, where this is the A equals 1. This is the B equals negative 7. This is the C equals 12. I want two numbers that multiply to A times C, which is 12. Those same two numbers have to add to negative 7. Okay. You always want to start with the multiply, right? Because there's only a few ways to multiply to 12. There's 1 times 12, there's 2 times 6, and there's 3 times 4. Okay. There's lots of ways to add to 7, but these are the only ways to multiply. And the way you're going to make both of these work is to take the 3 and the 4. Do a negative 3 here and a negative 4 here. That makes negative 7. Negative 3 times negative 4 equals positive 12. Okay? Because the A is 1, I can just put the x minus 3 and the x minus 4 in and be done with it. Okay? It's always a good idea to do a quick check. You can hopefully see here that that's a positive 12. Make sure your signs are right. You can also check that right here you have a minus 3x and here you have a minus 4x, and that's combined gives you the minus 7x that you needed up here. Okay, so that's always a good idea to do a quick check there. For this second problem here, okay, the A is 3, the B is 4, and the C is negative 4. So when I look for the two numbers that multiply to A times C, and those two numbers have to add to 4, again, I'm dealing with 12, right, which means I can reuse this box over here, but now I'm going to choose the 6 and the 2, right, to make 4. So I'm going to have to do a positive 6 and a negative 2, a positive 6 and a negative 2. And here's where I can't just say this is A plus 6 and A minus 2. That's not going to work. So a couple ways to go about it. Trial and error is probably worth learning at some point if you're going to do this a lot. You know that you need to get up to 3a squared from these two here, right? And there's only one way to multiply to 3, so it's got to be 3a and a, right? And then you also know that these last two have to be 4, which could be either 4 times 1 or 2 times 2. This is what we mean by trial and error. You just sort of make some guesses and try a few different scenarios and see what works. But if you've done this work right here, you also know that you have to get a 6 and a 2 when you combine your middle terms. And you might be able, with that 3a sitting there, to see that if you filled in a 2 here, that would give you 6. And if you put a minus 2 in here, that would give you a minus 2a. And lo and behold, this negative 2 times this plus 2 gives you the negative 4 that you needed. So trial and error could get you here. where you look around, you think about some of the possibilities. The more combinations you have, the more trial and possibly the more error you might have. But it's not a bad way to go, and it's something that you can learn in time. Okay, might be a little bit of a learning curve at first to try to get that down. Okay, the other option is to do the full AC method. So we'll take the 3a squared, and then we'll use the 6 and the minus 2, plus 6a minus 2a, and then the minus 4. Right? So the minus 4 comes down, the 3a squared comes down, and you're getting the 4a right, here by splitting up the 6 into the 6a and the minus 2a. Okay? And then what you do is you group and factor. Group the first two factor, group the first two factor. This is GCF factoring. There's a 3a common, a plus 2. There's a negative 2 common, a plus 2. And now hopefully you can see there's an a plus 2 common. Right? So that comes out first as the common factor. And then what's left behind is the 3a minus 2, which is the same thing I had before. Okay. Factoring is a big deal in this course. It's going to be a big deal if you're continuing on into, pre-calc and trig and then calculus. It's one of those things that you probably can't do enough of. If you did a few practicing problems every day or at least a few times a week, you'll get to the point where this is easy, and then hopefully that'll make all the rest of the stuff you learn even easier. Okay, so make sure you practice and keep these three techniques separated in your mind, and then learn how to combine them together.